Mosquitoes fitted with SCR-720 have a modified nose. The various components of SCR-720 are arranged as follows: scanner, receiver, control unit, indicator, and the rest of the equipment. The pulses of energy generated by the transmitter are fed to a dipole at the focus of a parabolic mirror. Just in front of this dipole, there is a small cylindrical reflector which concentrates all the energy onto the mirror. The mirror radiates this energy in the form of a conical beam having a mean width of 10 degrees. The dipole acts both as a transmitting and receiving aerial. So that energy is received only from the same region as is illuminated by the beam. In order to search the region in front of the aircraft, the mirror is tilted through a variable angle and at the same time rotated about a vertical axis. So if we imagine our aircraft to be at the center of a cylinder in space, the beam, when slowed up, would trace out a path on the cylinder like this during its upward tilt, and like this during the downward tilt. Since the scanner is in the nose of the aircraft, the beam will be lost in the framework during the time it is pointing backwards. So that only the energy that is radiated forwards can be used. This is how the operator would see this forward section of the imaginary cylinder if he followed the beam round with his eyes. The center of the beam can cover an elevation sweep from 20 degrees below the horizontal to 40 degrees above. But the extent of this elevation sweep may be selected in one of four ways. From -5 degrees to +10 degrees, from -5 degrees to +40, from +10 degrees to +40, or the entire sweep from -20 to +40 degrees. The desired sweep is selected by turning the elevation switch on the control box to its appropriate position. By means of another switch on the control box, the beam can be made to rotate continuously at -5 degrees without changing its tilt. In practice, the beam rotates 6 times per second and sweeps in elevation through 30 degrees per second. Returned energy picked up by the dipole is passed to the receiver. And displayed on 2 cathode ray tubes. The right-hand tube is known as the B scope. The presentation on this tube is of a special type known as range azimuth. This means that distance upwards from the bottom of the tube represents range, and distance outward from the tube center represents azimuth or bearing. This display is produced by a vertical time base which moves from left to right across the tube. The motion of this time base is related to that of the scanner. Thus, when the beam is 90 degrees to port, the time base is at the extreme left of the tube, and it keeps in step with the scanner until the scanner is 90 degrees to starboard, when the time base is at the extreme right of the tube. For the remaining 180 degrees of the scan, the time base is blacked out, since little of the energy is radiated usefully behind the aircraft. Thus, the time base moves from left to right across the tube as the beam illuminates the space in front of the aircraft. An echo appears as a bright horizontal blob with a width corresponding to 10 degrees on the azimuth scale. The target's bearing relative to the aircraft is found from the horizontal position of the echo on the tube. Its range is found from the distance from the bottom of the tube. There are 4 different range scales, the tube picture extending respectively to 3, 5, 10, and 100 miles. The required range scale is obtained by turning the range switch on the receiver.